The next project that I already built is actually really easy. I'll just kind of give dimensions. I realize it's already finished, but I guess let's start at the history. So a friend of mine, we call him Ras, he got a cool Jeep, and it had kind of a rack like this with the 2 jerry cans, and I would look at it and I'd say, man, I kind of want something like that. But of course I'm too cheap, and it looked like it could be fun to build, so we got the Ras rack. So we call him Ras. There you go, Ras. It's the Ras rack. So yeah, it's really useful. We took it out to Moab last weekend and used it. I mean, I didn't need the gas, but it's nice to have the ability. But normally my kids are sharing room in the back seat with a cooler and stuff. So this allowed us to put the cooler on there, and I got this Harbor Freight cheapy ammo can. I got some differential fluids in, and yeah, it's been really actually a pretty nice thing. So this tire mount is actually a worn rock crawler bumper tire mount, and so this rack I made, it actually inserts into it. The worn part, it's a 2x2 tube with an inside dimension of 1 3/4, and I could not find at my local steel shop a 1.75 by 1.75 square tubing. So this main construction is a 1.5 by 1.5 square tube 120 wall, which is plenty strong for what we got going on. And what I did is I took my 2-inch 1/8-inch thick plate and cut strips and welded them along the tube to tighten up that fit. That gives you the 1.75, and then I hit it with the grinder to finally fit, which we'll get filming at a detail I'm talking about here. These are 1/2-inch by 0.68 wall square tubes to make the rack. This section here is 50 inches, and so obviously this is 50 inches. I made it 8 inches tall, 18 inches wide. The jerry can mount is kind of unique. I'm actually grabbing the handles of the jerry can. I wanted to do that because you got a NATO jerry can and then like a World War II style, which I think these are. Basically, one has a rolled hammed edge and the other doesn't. This Smitty-built thing only handles the Type 3 edge, so this doesn't care because I'm grabbing the handles. And I pulled that off by taking the 2x1 tubing that I did in the last project for the half doors, and I drilled holes in the positions of the handles. The handles is like a tube, 3 tubes, so you can carry it. So I drilled holes and then I cut that in half and kind of ground it nice, and then I welded a 5/8 bolt so it's permanently attached, and then I got a nut welded in here so this fits up, capture it with this nut. I got a 3/8 nut welded on the other side so it clamps this, and then I have just your standard tie down strap for added surety. Right now I got these filled with water. I'm still kind of trying it out, running it around off-road, make sure nothing goes wrong. I don't want to put gasoline here and have some kind of horrible disaster. So yeah, it's been very stout, very stable. And then I actually sprung and got it professionally powder coated, and it looks really great. I'm probably going to have my half doors redone because it looks so nice. It just covers up so many gaps and flaws. Your welding doesn't have to be super beautiful. I bought these caps. You can get these from McMaster Car, these end caps. It's a lot easier than welding them closed like I did on the half door. And it gives it a cleaner, finished look. So yeah, that's the overalls. Like I say, 50 inches, and then as you see, I'm plugging in a socket into the top of the A-frame unit of the worn rack. I have another tube, you know, same type of tube laying, and this is positioned on top. So it's a 6-inch tube that drops into the A-frame unit. I drilled a cross hole and I bolted it, you know, to secure it in. I have actually a nut welded with a screw, get rid of any slop because I hate things jiggling around. And so yeah, it's been, you know, it's very rigid. I guess the next thing that I'd like to talk about in detail, this bumper system. Warren has a sticker right on it that says don't exceed 150 pounds on this unit, and I'm drastically exceeding that because this sets the tire wheel combo is 87 pounds. This giddy up here is easily, well, I think Smitty built rates this at about 38 pounds plus this junk I have on. I'm easily 50 pounds there, plus these two cans, like I say, are about 80 pounds with water. With gas, it'd be about 60. Gas is lighter. The rack itself, it wasn't super heavy, but I haven't weighed it yet, but I think it's less than 30 pounds. So, you know, I'm not the type of person, and nor should you be, just it'll be okay. You know, the engineers that designed this bumper know what they're doing, and so I'll take a look at the bumper design and talk about things I did to kind of shore this up so it can handle the added load. Okay, so I'm going to run through some calculations that I did to determine, you know, what's going on with this bumper. Why did they rate it, you know, at 150 pound load? So the bumper is attached to the frame of the Jeep with a sheet metal bracket that's about a 1/4 inch thick. They attach it with 7/16 bolts. You can find the installation instructions online from Warren for the rock crawler bumper, but my bumper is configured, like I got about 250 pounds that I'm dealing with, offset from those bolt locations about 2 feet. It's actually less than that, but it's good to be conservative. And you got a pair of 7/16 bolts spaced out 1 1/8 apart. And so I'm going to calculate the reactions about the centroid of those 2 bolts to determine the load that this thing sees. So it's kind of easy because there's a pair of bolts there. The centroid is obviously in the middle of the 2 bolts, and so I'll sum the moments about the center of the 2 bolts. I'll call that position A. Determine the reactions, and so you have a moment of 250 pounds times 24 inches that is trying to turn, you know, rotate the centroid of those bolts in a, say, clockwise direction as we're looking at it. And then the reactions react opposite. So you got reaction 1 times half of that 1 1/8 distance. So both of those sum together, put this system in equilibrium. If you sum the forces in the X direction, which would say it's horizontal, you're going to see that the reaction of the first bolt is equal to the second bolt. So the reactions in the horizontal direction are the same. So you come up with this equation. You find out a reaction is 5,328 pounds. Well, you got 2 brackets because there's one on the left and right passenger driver side of the vehicle. It's going to cut that in half. That takes you down to 2,664 pounds per bolt. It's 7/16 bolt. Anytime I've had to design a bolted joint, taught to design it such that the friction afforded by torquing the fasteners is what you want to counteract the loads. You don't want the actual fastener to carry the load unless it's like a rivet or something that fills up the spaces. A bolt doesn't act that way. So the instructions actually instruct you when you're putting this together to torque those 7/16 bolts. We're talking 46 foot-pounds. So that's 552 inch-pounds. So quick and dirty way to determine the force generated at that torque is equal to K, which is a friction coefficient. The force, the actual force of the bolt is in that equation, and then the nominal diameter of the bolt. And so because we know the torque, the friction factor, a lubricated screw, you can look these up, but I'm going to use 0.18. And the nominal diameter of a 6/16 bolt is 0.438. So I solve for force bolt. That comes to, looks like 7,009 pounds. So that's the kind of force that's generated by that spring, really. Your bolt's a spring. But the friction is mu times n, n being the force of the bolt in this case. Friction factor, it's a static scenario, so again you can look these up. Steel on steel, I found it at 0.4. So you're getting 40% of 7,009 pounds, which is 2,803 pounds, which is greater than 2,664 pounds reacting. But that's pretty darn close to me. So of course Warren designed into this thing a safety factor, but with 250 pounds on there, that's closer than I want to go. And so I will take some steps to mitigate that, which I'll show you. This is a thing I did to mitigate the overload scenario on this bumper bracket attachment. Again, I took a section of my 1/2x1/2 tube Jeep mounts their spare here. I figured, why don't I just tie into there to you know, kind of counteract and give additional support to this, because you know, like in this case it's okay, but if I were to drive it around like this, it would probably rip off. So the main concern is when it's closed. So I took a section of my tube, I cut it at 45s, and I picked up, there's 4 threaded holes into the tailgate of the Jeep. I guess this is the tailgate. So I set this up to attach to those 4 points, and then onto the A-frame I did a similar thing, 45 degree, drilled a hole such that I could drop the pin. I welded this on, and gate is closed. I couple this to that with this and the hair clip pin to secure it. And this has been pretty effective. Another thing that I did, and this is kind of Mickey Mouse. I took a piece of the 2-inch eighth plate. So I took my 1/2x1/2, I welded these together, put a couple welds on the end, and then I welded here in these 2 places to you know, provide additional support to that overturning moment. They say this is Mickey Mouse because it's kind of like welding the bumper to the vehicle, but I did it this way. In the event I had to remove this, it's very easy to grind that weld and take it off if I had to remove the bumper for whatever reason. So these 2 things are what I've done. I guess another detail that we talked about, this is the cross bolt. These are the little spacers to kind of thicken this up so that this fits better into here, but I'm bolting this, I'm tightening, I'm clamping it, and then I have a nut welded here, 1/2-inch bolt that actually pushes on this so it holds it straight. So when I close it and latch it, you know, I'm just carrying the load into the tailgate. So it kind of worked out nice, and to this point it's been pretty stable. You know, in Moab we were okay with it. I actually didn't run it around with full tanks. We took it on an off-road trip this weekend. Nothing too hardcore, but yeah, these were stable. That's that. That's the RAS rack. Make it. I think I'm into this about $35 in steel. So the powder coat job was $120. That was the most expensive part of the project, but it really did a lot for aesthetics. I mean, to me, it's kind of dirty now, but it looked like something you could buy, or I don't know. And you know, this has proven so far to be, you know, successful. It's kind of a unique way. You know, I have my tie downs as added insurance, but yeah, yeah, go for it. It's easy to make, and it's actually a nice thing to have. It enhanced our little trip, and I got plans maybe to take it camping now because it gives me that ability. Thanks for watching. Subscribe, and hopefully we can put some more videos out. Thanks for all the nice comments.